Welcome, Mrs. Mahoney's podcast. This is our third and final one for Unit 10. So that does mean down the line, what is it, next Thursday, I believe, is our test, or Wednesday, the 3rd. Actually, looking at that with the EOC English test, that test on the 3rd might actually get moved to the 4th, and we'll talk about that in class once I look at all the calendar, and we'll just make sure that you are prepared for that test. Okay, for today, you're going to need your packet, obviously, and we're on page 12. You need your periodic table, and you need your calculators. So if you need to pause me, don't you wish you could do that in class? Not mute me, but if you need to pause, go back and go get all of that, because this is the only math of this section. We could do some stoichiometry with solutions, but I've decided I'm going to wait and do that after the EOC because that is an extension. So let's focus on what you're going to see on the EOC in that test in May, and then afterwards we're going to do the extensions. Okay, so the math. The nice thing is this is a math that is just, again, using a formula. I think it's an easier formula, so you just have to make sure there's two different ones we're going to be looking at, and when, it's kind of like in the gas laws, you need to know when do I need to use which formula. Both of these are on your formula chart. So if you're looking at your chart, this is how it looks. Molarity, and this is our capital M, is just moles over liters. Okay, one thing if you do not know, I would write down, right now, make sure you know that there are 1,000 milliliters equal 1 liters. 1 liter. That is not given to you. It will not be given to you. You do need to use that because you will see this. Okay, concentration, we've talked about that. What does that mean? We say something is concentrated or dilute. Concentration is a way of telling me how much solute I have dissolved in that solution. There are different ways. You've probably heard on TV shows, or if you've ever had to go to the doctor, they'll do it more as a percentage. A 5% saline solution. That means 5% of that solution would be saline or salt. You can do it parts per million. If you ever heard anything and they're talking about that there was 50 parts per million, and again, it's telling you what's the concentration. The part is, they're saying if you have 50 parts per million, that means there's 50 parts of that solute in a million particles of the solvent. So that's what a concentration is. Again, it's just telling me how much solute do I have in the total solution. So it's almost like, again, a percentage. It's the part over the whole. So the most common one we use in chemistry is molarity. So you can see right here, foreshadowing, yes, we're going to need moles because it's going to say how many moles of solute do I have in a liter of solution. Okay, picky details. When you label it a capital M. It matters. And the reason is a little m, sometimes we use it for mass, but when we're doing solutions, a little m actually stands for molality, which we won't be using now. Next year in AP Chem, we'll be looking at some molality. They also have a normality, where we're not going to mess with that. So if you see, we're really just going to look at the one. It could be a lot worse, so let's just take the one and make sure we know how to do that. So looking at my formula, I need to have three things. Molarity, moles, liters. So like in any problem, I'm going to have to be given or know how to find 2 out of those 3 in order to solve the problem. So let's just jump in and look at this first problem. What is the molarity? That means right there I can tell, this is what I'm going to be looking for, of a 355 milliliters. Now this is where, if you look at it, a lot of times I use V or volume. So V, liters, same thing. You'll see me using these interchangeably. Just realize V is the volume. The volume needs to be in liters for a molarity. So for the liters, if I have 355 milliliters divided by 1,000, that would be 0.355 liters. Okay, so then look what I have. I have grams. What do I have to do to these grams then? With these grams of glucose, I need to change them to moles of glucose. So how do I do that? Yep, molar mass. So that's why you need your periodic table. 6 times 12 plus 12 times 1 plus 6 times 16. And we get a molar mass, and I'm going to use it to 4 significant figures because I'm going to use more than it gave me. So use your molar mass, 180.2 grams, And this is going to tell me how many moles do I have. So I have 0.222 moles. Now one thing when I'm calculating molarity, now I might write down just the 3 significant figures, but I tend to leave this number on your calculator. Don't clear it. Just leave that whole number written on the calculator. I rounded it to write it down. But then what do I know? I need to put that mole over my liters. And then I just divide it by your 0.355 and then round at the end so that your significant figures are not rounding and rounding. Because every time you round, there goes your error a little bit. But I do want to put it to 3 significant figures, so I have how many moles in this many liters. What is that concentration? It's a 0.625. Label it a capital M. And a lot of times we'll say that's a 0.625 molar solution. Okay, think back to labs we've done and you've seen that. It said it's 6 molar hydrochloric acid, 1 molar of this. That's a concentration. This is actually something that's very, very usable in the chemistry, and I do this math all the time when I have to make up solutions. Okay, and this is actually how it kind of works. Let's look at number 2, because this is what I have to do. Most of the things that we get are solids, and so I have to figure out how much do I need for the lab and of what concentration. So this is going to tell me then how to make that solution. And we're actually going to practice doing this. You're going to practice making the solutions like I do and look at that process. So to determine the mass to make, let's look at what I know. I have a volume, which is already in liters, so I do not change it. I know my concentration is 1.75. That's a point. So I'm missing the moles. And you have to solve for moles before we could solve for the gram. Okay, so you put down what I know. I know my molarity. I do not know moles. And I know my volume. Okay, how do I solve for that? Cross multiply. That's what this was doing right here. This was where I'd done the math ahead of time, so if you just want to jump to that, we could have done that too. Just want to show you how did that happen. What is moles? It's molarity times liters. That's where that came from. So you cross multiply and you get that you have 4.375 moles. Notice again, I'm not going to round till the end. Okay, cool, moles, am I done? No, that doesn't help me back in the lab when I'm making it up. I need to know mass. Well, moles to grams, you're going to have the formula, barium nitrate plus 2 minus 1. You need to have the molar mass of barium nitrate, which is 261.3. That's a big M, moles. So last step, just take those moles. I know I have 1 mole is 261.3 grams. Now I'll just multiply, then I can round it to 3 significant figures in my final answer. So I would need 1,040 grams of barium nitrate in every 2.5 liters to make this concentrated solution. That's a lot of barium nitrate. Well, that's a pretty concentrated solution. So that makes sense, and I think that that's perfectly fine. Okay, now just trying to show you again examples of different ways you could see it. Let's look at this one. And sometimes you just really have to visualize what you're doing to solve the problems. Because if I look at this, I have milliliters of an ethyl alcohol. Well, I need to get to moles, which means I need to get to grams. So that is why I give you the density. Difference is usually it's water, density is 1, you just multiply. This one just has a density 0.8, we can still use dimensional analysis to solve it. But let's also look at how it's going to affect the concentration. So first when I look, okay, what are my liters? Let's look at what I have. In the total beakers that you're going to have, I have 50 milliliters, and then what did I do? I added it with 100 milliliters. So what is your total volume of your solution is 150 milliliters. But again, that needs to be in liters, so that's a 0.15, ignore that one, 0.1500 liters. The reason I put those other zeros were to keep my significant figures. Okay, now let's figure out how we're going to figure out the moles. How do I figure out the moles? Well, first we're going to have to figure out the grams. So if I have 50 milliliters, what do I know for its density? Well, 0.8 grams is for every 1 milliliter. So by setting density, and this is what we're doing in our head when it's just a 1-to-1, you're just multiplying it, doing the dimensional analysis. So if I just multiply 50 times 0.8, that tells me I have 40 grams of ethanol. Well, ethanol, I need the molar mass of ethanol, and that's 46.07 grams per mole. So that's how many grams, but it needs to be moles. So I'm going to just figure out divided by molar mass. That's telling me that I have 0.868 moles of my ethanol, but it asks for a concentration, so I have that many moles in that many liters. So take your 0.868, and again, I left that number on the calculator. I know it actually goes further than that, and so to keep it more accurate, then just divide the number on your calculator by 0.15, and you get a 5.79 molar concentration. Okay, I want you to try number 4. Now your answer you should have gotten for number 4 is just a concentration. Your answer should be 0.365 concentration should be your answer. Okay, let's look at the second type of formulas you have, and it's a dilutions. Dilutions are, again, one of the very common ones. In fact, when I had an interview for a job, they made me do this formula to prove I knew how to make dilutions. So if you worked in the field or worked in industry, this is a very common. Because again, I don't buy concentrations and varies. That'd be expensive. You buy something very concentrated and then you dilute it down to what you need. So this is your formula. Now on the formula chart, they decided to take the most common one, M1V1 equals M2V2, and switch it to V1M1 equals V2M2. I'm sorry, I cannot say it like this. It works exactly the same, but for so many years it has been in my head, M1V1 equals M2V2. That's just what's in my head. So realize this is what it looks like on the formula chart. It's exactly the same thing. M1V1 equals M2V2 is just what is in my head, and I'm too old to change. So with this, same thing. You're going to have to know 3 out of the 4. You need to know what 3 out of the 4 are. So you need to look at it and just write down what I know. And the main thing is make sure you put which volume goes with which concentration. So reading this, what concentration results? That right there tells me I'm looking for the new concentration because I'm going to change the concentration. When water is added to, so now as I'm reading through this, I know that I have V1 is 500 milliliters. And how much of that do I have? It's 500 milliliters, and it's of a 12 molar. It's concentrated. To prepare, this gives me a V2, 2 liters. Okay, M2 is what you're looking for in this one. Now with this, you don't always have to be in liters, but they do have to be the same. So that's what you have to look at first. Are they the same? If they're not, you need to change one of them. So I'll just go ahead and change this one to liters because they need to be the same. Okay, now plug them in. Plug and chug, plug and crank. I still call them plug and chug. Guess I'm, again, too old to change. Plug it in what you know. What do I know? M1 is a 12 molar. We change this to 0.500. That's in my liters, so I know everything's going to cancel. I want to know my new concentration, and I know that I have 2 liters. Okay, to solve for x, multiply 12 times 0.5 divided by 2 because you have to divide by whichever side's being multiplied. Don't let the algebra make you mistake here. Now again, a double check. If I'm diluting it, my answer better be smaller, less concentrated than the one I started with. If you had something that ended higher, then you did the math wrong. Go back and look at it. And what do you end up? You end up with a 3 molar solution. So this is how concentrated. You've diluted it down. I do this all the time in the lab because I don't want you to use 12 molar hydrochloric acid, so I dilute it down to the concentration we want. Okay, let's look at number 6. A 3.34 molar solution is diluted by adding 35 milliliters of distilled water to 50 milliliters of solution. Again, picture these. These are where I'm going to do some of these labs so that you can realize what the word is, if you can visualize what you're doing, then you can put numbers. It's not just memorizing the numbers. What do the numbers mean? So that 3.34 is what I'm starting with. Okay, is diluted by adding 35 milliliters of water to 50 milliliters of the solution. So that means I only used 50 milliliters of my 3.34. Okay, so look at picture what I had. And this is where if you can imagine it. So I had 50 milliliters. Then what did I do? I added another 35 milliliters of water. So what is my final volume then? Would be 85 milliliters. And you want to know, what is this concentration? Okay, so if I look at that again, the math is going to be the same. 3.34 in this one. And I had 50 milliliters of it. I want to know what's my new concentration when I've added enough water to now have 85 milliliters. Notice I didn't have to change them to liters because they were both in milliliters, so they were the same. So 3.34 times 50 divided by 85. And so this gives me a new concentration that should be smaller than my initial concentration of 1.96 molar. Okay, I had added 7. I don't have that one with me, so I want you to try number 7, and I'm going to say really picture it. And this would be a good one for us to kind of talk through as we're going through tomorrow. So picture what you're doing, and notice I'm asking you 2 things. I'm asking you how much you need of your concentration, so my hint to you, you're going to have to look for V1. This is my hint. You need to look for V1. It's going to be your unknown. And you also have to tell me the amount of water. I want 2 answers. Really try this one, and we'll work on that tomorrow and come with the questions. Have a great day, and I will see you tomorrow.